We'll just give it a couple minutes, maybe 1 minute or something like that for more people to show up, because this is the last session of TestMu 2025. Some folks may be shuffling from another sessions, and we have multiple sessions running in parallel. So for folks who have joined in so far, thank you so much for being here, being a part of TestMu 2025. Myself, I'm Harshit Paul. I'm joining in from New Delhi, India. And I have with me Sam Julien, who's from Vancouver. So we are sitting at in almost diagonally opposite time zones, right? So uh, almost there. So let us know where you all are tuning in from. Feel free to chat, react the way you're doing on with emojis. Let us know. It'll be good to know if you're tuning in from different parts of the world. Before we get this started, Kunal says, "Hey, hello, good day from." All right, hey Jim, good day. Thanks for joining. I see Sam is already engaging on the chat as well. Hello from Berlin, Gisland. So we have people joining in from different parts. That's always interesting, Sam, isn't it?
Yeah, that's always great. I love Berlin. I got to go there a couple years ago. Great place.
Oh wow. I will probably be adding that to my itinerary someday. But
For
yes, I
sure.
think like we'll be 2 minutes in, so it's a good time to start the session. Good morning, good afternoon, and good evening to everyone who has joined us in, and thank you for being a part of TestMu Conference 2025. I am Harshit Paul, Director of Product Marketing at Lambda Test, and I'll be your host on this session where we talk about the shift from SDLC to ADLC, the Enterprise Agent Development Lifecycle. Whether you're new to AI or a seasoned engineer, today's conversation promises actionable tips, deep dives, and vision for the technology's next chapter. But before we get started, a few housekeeping items. This session is recorded, so in case you need to drop off at any point of time, you will be finding that recording over your registered email address. Feel free to drop any questions that you might have while we are presenting on the Q&A box to the right side. We will be picking them towards the end of the session where we have a dedicated Q&A round. And with that, I welcome Sam Julien, Director of Developer Relations at Writer, a truly innovative leader in the world of developer relations and AI driven technology. Sam has been instrumental in helping teams unlock the potential of AI agents, bringing both strategic and practical insights to the ever changing tech landscape. Thanks for joining us, Sam. It's great to have you here, and the stage is yours.
Thank you so much. Okay, let me share my screen here. All right.
I can see your screen fine. That's great.
Awesome. Well, great. Thank you so much. It's great to be here. This is from SDLC to ADLC, the Enterprise Agent Development Lifecycle. So we're in this really interesting situation right now where it's becoming increasingly easy to prototype AI applications and agents. You can use a low code tool or vibe coding tool. We'll get something up and running in just a few minutes. You don't need a spec, you don't need production infrastructure or anything like that. But then, how do you actually get that into production? This is a big challenge still right now. And a lot of our traditional methods are not really working. And then when you look at that from the perspective of the enterprise, things get even more complicated because you're dealing with things like compliance requirements, IT bottlenecks, poor quality data, legacy systems, all kinds of things that make it just that much more difficult to apply sort of our traditional software development practices in the space of AI engineering and AI agents. So I work for a company called Writer, and we've been dedicated to this problem for several years now of really building enterprise grade AI and agentic systems. It starts with our foundation models, our Palmyra family of models. These are some top ranked models that we build in house. And we do that because we want our customers to have reliability and predictability, which is hard to achieve if you're built on top of a third party model that could change at any time. And then we also have built this agentic platform end to end for enterprises to build AI applications and agents. So we're working with hundreds of Fortune 500 and Global 2000 companies to actually build real agents in the enterprise. So what I wanted to do in this talk was share a lot of the lessons that we've learned as we've been working with our customers, with the community, so that you could hopefully gain some insight. And what's interesting is that we're finding that where a lot of enterprises now, the problem isn't necessarily technical. Like the models are getting better and better, the frameworks are getting better, memory approaches are getting better. Now, what's really happening is that the problem is in process and organizational change management and that kind of thing. Enterprises are having to kind of unlearn a lot of our traditional SDLC practices, or think in new ways. So, what I want to do in this talk is talk through what you build with AI agents in the enterprise, who builds them, and how you build what we call the agent development lifecycle. So I'm Sam Julien. I'm the director of developer relations at Ryder. I lead developer relations and experience. We do our docs and SDKs, our technical content, our enablement for our customers who are developers. And I'm on social media everywhere as Sam Julien, so please reach out. So let's start with what you build. So last year, which in AI terms is like last century, we were focused a lot on basically layering generative AI on top of traditional software or SaaS. And these were AI applications that dealt with assigned tasks and fixed logic, and they would respond to inputs and generate outputs. So this would be things, generate a report, generate a frequently asked questions, analyze some data, and build a chart or something like that. And now we're in this world of agents, and it's a totally different landscape. You're dealing with agents that are assigned outcomes instead of tasks, like go build me a research report, or go build this feature in code for me. And you're dealing with adaptive behavior, agents that have to be flexible and adapt to whatever inputs are being given to them. And they also need to have the ability to respond to their environment and take actions and make decisions. This is especially true of agents that have access to computer use, where they're having to see what's on the screen and make decisions and enter commands and things like that. So we're in this very different landscape. So, how do we navigate this? What we found working with our customers is there's kind of this spectrum of autonomy. And the first thing you need to do when you're trying to build out an AI solution is actually determine where on this spectrum of autonomy you need to build, because you only want to, you want to use code where you can and deterministic processes, and then use AI where you need it, use LLMs where you need it. So on the left side with no autonomy, this is sort of what we were doing last year, of like structured prompts and clear guardrails, predictable outputs, things like generating frequently asked questions and expense policies and things like that. And then on the other end of the spectrum is the full autonomy. These are the open-ended tasks requiring complex problem solving. So things like coding and deep research. Those are sort of like the proven use cases at this point for these high autonomous agents. And then we're finding that for a lot of enterprises, it falls in the middle with this hybrid where you have these deterministic processes where you need LLMs in like specific decision points. So maybe you have a contract review workflow that has rule-based checks, and then you need an LLM to do some semantic analysis for different terms or that kind of thing. So first thing you need to do is figure out where in the spectrum your system needs to be. And this is super important because a simple solution that works 95% of the time is going to take you a lot farther than some sophisticated system that you build that only is working 80% of the time but costs you 10 times more. So once you've figured out where in that spectrum you fall for your agentic system, you can start looking at mapping out the process. We like to say that process mapping is the new prompt engineering, because this is probably the most crucial piece of the agent building process. You want to look at things like the frequency of the process. How often does it kick off? Is it weekly, monthly, ad hoc? You want to look at the actual sequence of events that happen in the process. So, for example, if you're trying to build like a fund commentary analysis agent or something, what are the actual steps that need to be taken? What kind of actions does it take? And then who are the stakeholders that are involved? Like which parts of the business need to actually interact with this agent and need to have a say in what's going on with it? What happens within the process? Is there like an approval process? And then what are the deliverables? So is it like a report? Is it a spreadsheet? Is it a piece of software? What is it that we're actually trying to accomplish with this business process? And then lastly, what kind of systems does this process touch? Does it need access to Salesforce? Does it need access to Snowflake or some other database system? And that's how we're going to start to like work through what we're going to build with this agentic system. Once you do that, you can actually literally map out the process and figure out which stakeholders are doing what to actually understand the process that you're going to transform into an agentic system. So here's a real example from a Fortune 1000 finance company that was basically generating thousands, like 8,000 market commentary reports in a year. And it was this manual, slow, error-prone process where you got to, get all this information and submit it to compliance and then file it and all of this. There's a big, long process. And so we helped them map out the process before we started building anything, which is super important. Because then once you've mapped out the process, then you can actually use the kind of atomic pieces of building an agent to figure out what you're actually going to build. So you're going to look at the triggers for an agent. So for example, like when should this kick off? Should it be when you get a chat message, when you somebody clicks on a button, or maybe it's system initiated, like more information comes into Salesforce and you need this to trigger. Then you need to look at the inputs that you need for the agent. This is basically the context that need to be processed to generate the input. So it could be uploaded files, it could be metadata, something like that, or connected data sources. Then what are the outputs? What are the artifacts that the agent are going to need to produce for the next step? So this could be like blogs or summaries or analyses, could be structured data like JSON. And then once you have that, what are the actions that the agent is going to need to take, both with or without a human? So, for example, it might need to send an email or update a record or create a ticket. But then there also might need to be a human who can do things like review something or confirm or accept edits or approve. And then finally, what are the decisions that the agent is going to need to make? What kind of logic are you going to need to have in this agent? What if, maybe if the market moves over 50%, update the commentary. And then there might be judgment calls, like when to escalate a ticket or when to monitor a situation based on analysis. So you want to define all of these things to let the agent adapt their behavior. So going back to that example I mentioned of the market commentary, this process is really important because you don't want to waste a whole bunch of engineering time mapping this out. So we mapped out this process with our customer, and this was like a 2 to 4 week process usually, the market commentary process that they were doing, and we got it down to a 5-day process. And part of the magic there was actually determining when we don't need to get AI, like what is deterministic and what is non-deterministic. So for example, we went and got data from Snowflake, sent it to our API, and then it invokes this research assistant and generates the commentary. And then that commentary can get sent to Quark and populate a template. And then we can bring in the portfolio manager and the compliance approval and all of that. And that has a real business impact that saves them a few hours every single occurrence, but it happens 8,000 times a year. So that's almost $2 million a year that they're saving just by taking the time up front to define this process and work through it before actually building something. Okay, so that's the what that we're building. Let's talk about who's building, because this is a really interesting evolution as we move into AI agents. So we find that for a lot of customers on the enterprise side, they still have this expectation that it's going to be AI or ML engineers that are going to build these kinds of solutions. People who are actually like building and training and fine tuning models or building the infrastructure around AI. In reality, what actually needs to happen is that the software engineers and business teams need to collaborate on building these agents together. And it's a really interesting evolution because the role of developers with the business stakeholders are overlapping in a lot of new ways. Um, so when we're building traditional software, a lot of time success is pretty quantifiable and clear. It's pretty kind of binary. We know whether the requirements are met. But with an agent, you need to know a lot of business domain knowledge to know whether you're on track with the agent. Same with if it's using tools or data efficiently. Like a developer can know whether or not a tool is being called or data is being used, but the business user who actually understands the domain is the one who's going to understand whether it's actually using the right tools and whether the data is being like used efficiently. And finally, uh, a developer can identify when an agent is, you know, not performing a certain way, but a business user will actually be able to have the judgment to know when it's a problem or not. So, like if you were building an agent for a request for proposal agent, where like when an enterprise needs to buy software, they do a request for proposal, and companies send in information, and you read through them and everything, right? Uh, and first of all, it may be a good example because maybe you have no idea what that is. And that's exactly why this is so complicated. But like if you're building that RFP system, you're going to need to understand things like the quality, like what themes will resonate with the end recipient of these requests for proposal. Is the tone and the writing compelling? Are the business terms correct? And that's very difficult for a developer to just know off the top of their head. The efficiency is also a big part of this, where if the agent escalates a question to a subject matter expert, maybe they escalate to 4 subject matter experts, but they only need 2. That's very difficult for a developer to be able to assess compared to a business user who's familiar with the domain. And likewise, there's judgment involved. What if the RFP agent gets multiple RFPs at the same time? How do they prioritize which one to process first? That's very difficult to actually put in requirements for an agent. So as we've been working with our customers, we're seeing a lot of new roles develop as part of this process. And we've broken this down into agent owner, who owns the agent outcomes in the life cycle. They're sort of like the PM for the agent. The builder, who scales the agentic design system. The champion, who drives the adoption and momentum, because you don't really want this thing to just get built and then languish and nobody uses it. And then the supervisor, who has to actually govern the ecosystem of agents. Because if you think about it, agents are actually, they're making a dent in the real world. They're actually using provision tools in the real world, and you need to actually govern their behavior. So I'll drill a little bit deeper into 2 of these. First is the agent owner. This is typically someone who's in like a non-technical AI transformation and innovation role. And this is the person who owns the agent outcomes and lifecycle. Like I said, they're kind of like the PM of the agent. So like a product manager. But what's interesting here is they don't just need to be able to drive the development and the impact. They also need to understand the prompt engineering and context engineering to be able to provide to the builder. So they're going to do some prototyping, they're going to do the process mapping, and they're going to be able to help refine the prompts and put together the different contexts needed. On the other hand, the builder is also an interesting evolution of both IT and developer roles, where this is the person who's going to be focused on actually like scaling out the agentic systems. So they're going to need to understand things like systems architecture. They're going to be responsible for things like API integrations and key management, and then also testing and deployment processes. So of course, this is not just going to be one person. This will be, people who are like backend developers and automation engineers and solutions architects. But what we're seeing is that there's a lot of blurring of the lines here with the different agent processes out there, where there's some things that are kind of traditionally developer tasks are falling into solutions engineering. Some things that are typically uh, IT tasks are becoming developer tasks. So that's why we've come up with this builder term to kind of encompass all of that. So here's an example from a real company. This is from a retail brand that we work with, and we were building them an SEO agent. And you can see that the orchestration and the custom integrations were handled by the builders on this, but then the prompt engineering and the out-of-the-box integrations were handled by the agent owner. So you have things like the agent owner doing things like helping figure out the product description page copy, and the SEO copy, and the product imagery, or the SEO and copy images. But then the builders were doing things like actually processing the data and uh, dealing with the error handling and things like that. And this is super important because the way you do this division of labor has an actual impact on the quality of the outputs and the ability to iterate. One thing that we found is very important is to enable the non-technical users to actually own the prompting layer. Because the last thing you want is to wait on a change management process just to tinker with the system's prompt for an agent, or maybe a series of prompts. You don't want to wait to have to like fix that in a database somewhere just because you need to change a few words in the prompt. And we all know that changing a few words can actually have a huge impact on the output of that an LLM gives you. Okay, now, lastly, let's talk through the agent development lifecycle, or how you build, as we look through this mental model shift. So the typical software development lifecycle is not going away. I mean, we still need that. Of course, now we have more software agents that can actually take over parts of this process. But what I mean is that the agent development lifecycle is sort of a layer on top of the SDLC now, where you have to think about these new dimensions as we progress in this process. So first, in addition to requirements, you really need to think about outcomes right out of the gate. That's not to say you don't already think of outcomes when you're building software normally, but with agents, it seems to be a particularly pressing problem because there's just such a wide field of things that you can build. What typically we see is that like a CEO or a board member of a customer will be like, we need to get started with AI. Like, we got to build something with AI. Maybe we'll do customer support or something like that, right? It's very vague, and you're sort of like, okay, well, we could build any number of things here. And so there's no real clear owner, there's no defined metric, there's no business plan. And so what we always work with our customers on is like, let's push for a clear problem with a measurable impact, such as we want to reduce internal ticket resolution time by 40%. That's a metric that you can see if you're actually making a distinction. So you want to find a problem that's keeping people awake at night and actually clearly define it. Because otherwise, like with most software development, you're going to have scope creep and feature bloat and all kinds of problems. And that's going to really prevent you from getting something into production. So then on the second part, we're used to doing process design, but now we also need to do behavior design. This is the wild part about AI agents is you're not just like shipping software, you're shipping this like entity that's going to be acting in the real world. And that's got all kinds of impact that you need to be aware of. So what we're finding is you really need to have this MVP mindset, even more so than traditional agile. It's like you need super hyperactive agile where you can't really do this sort of endless fine tuning before you ship. And this is a real thing that is happening all over the place where um, projects just sort of die because they're just spending so much time tinkering with it, they can't ever ship it because they keep finding an edge case and things like that. So, what you need to do is ship a 70% solution, but make sure that you have fail safes and guardrails in place and that kind of thing to where you can have an MVP tied to outcome that delivers value in weeks. So here's an example of like a quick MVP agent. This was an agent that a colleague of mine built for just gathering fund performance for a growth fund. So what's nice about this is it's modular and very clear about what it's doing. So first, what it does is it goes and gets fund data from Snowflake after a Slack message. Then it analyzes it, charts some plots, generates a fund analysis, and then sends you this report. So pretty straightforward. And we're using Slack here as like a just proof of concept UI. And so then we can use that to see whether this is a viable solution, and then we could build it out. We could build out a custom UI or whatever we wanted to do with this. But what's great here is that it's so modular that you can know which part is underperforming and which one needs help. Okay, so then normally we're focused on development. What's interesting about the agent development lifecycle is that scaling is all of a sudden a first class citizen. I think as developers and testers, we're sort of used to this idea of scaling resources either vertically or horizontally based on the demand of users. But With agents, you have all of these second order effects because they're actually interacting with the real world. And so you actually need to like plan for scale immediately, because the danger is that you're going to end up spinning up a brand new agent for every single use case in your company, which is going to lead to all kinds of like one-off use cases and inconsistent behavior. And then most importantly, for like IT and compliance, there's no real path to governing all those agents and keeping track of them. So you need to start out with this idea that you're going to build this reusable agentic design system where you can have reusable prompts and logic and patterns and consistent governable experiences so that you can get people up and running quickly and you can enable those business users. So then this is probably everybody here's favorite subject. In addition to QA testing, you need evaluation, or what's commonly called evals, for agents. And this is probably the most important part of this whole process when it comes to building agents, because unlike traditional testing, you don't really have very many binary pass fail scenarios. I mean, there are some that you can do, but you don't have many objective test cases, because you're also trying to go for reliability in addition to predictability. You need to know that this agent can actually behave reliably enough to be trusted. So you're going to need to know that it can follow guardrails and that there's fallbacks and fault tolerance, and that it's going to escalate based on some sort of confidence threshold or things like that. Um, how you evaluate the agents is a great subject, and I wanted to point you to my two favorite luminaries in this area, Hamal Hussein and Shreya Shankar, who are doing a lot of work on AI evals. Highly recommend you consume everything they've written on this subject. But one concept I wanted to share was that they have this three gulfs when it comes to building AI systems. And that's the gulf of comprehension between the developer and the data, because as we mentioned, the developer doesn't have all the business context. So they not only do they have limited bandwidth because they're humans and can't read everything, they also are not going to see the errors and the outliers very quickly because they don't have the deep subject matter expertise. Then we have the gulf of specification between the developer and the LLM pipeline. This is because the developer intent is going to be hard to communicate. It's such a specific um, uh, business process that you're dealing with. So the prompts need to be very detailed and data specific. And then lastly, you have the gulf of generalization, where between the data and the LLM pipeline. The LLM behavior might vary wildly across the different types of input you have. And the approach of how to improve them through evaluation is going to look different depending on what you need to do. So you might need to do task decomposition through your prompting. You might need to do some fine tuning. You might need to swap out for a better model entirely. You might need to build a RAG system. There's lots of different ways that you can do this. So what do we do with all of this? Well, what I love about what Hamel and Shreya have done is they've put together this process where you first analyze the traces of the information. First, you instrument your agents so that it emits trace information. And then you can collect the representative examples and categorize the failure modes. Then you measure that, translate that into qualitative insights, into quantitative metrics, and then improve on it. Take that information, refine the prompts, refine the model usage, refine the pipeline architecture, and continue to iterate. So next we have deployment and rapid iteration. So with agents, there's really no definition of done. You're going to be constantly iterating on it. And this is because we're versioning behavior, not just code. Behavior is going to shift without code changes because we're dealing with models and memory and tool calls and things like that. You're going to need to find a way to version control things like your tool schemas and handlers, your memory configs, your model settings, things like that, because agents are going to continue to evolve post-launch. So this is just another example of a fun commentary agent, kind of building on some of the previous examples. This is a schema where the blocks that run horizontally run sequentially, and the blocks that are vertical run in parallel. And essentially what happens here is that we get a Slack request, or we get a new data upload that goes to an LLM that does some tool calling, and then that gets sent to either various HTTP requests or some other agents that do things like do research or build market commentary. And this is just sort of an illustration of the modular approach that you need for the different type of collaboration amongst the business and the developers, right? Because the business user can do things like tinker with the prompts for the research assistant or the output formatting for the commentary, where the developer can go in and troubleshoot the Snowflake connection, the Salesforce connection, that kind of thing. Okay, lastly, on top of maintenance, we have supervision. So we're used to a world where maintenance is a big part of software development, can be the most expensive part of an application over its lifetime. But with agents, you're not just dealing with straight behavior, you're dealing with actual behavior in the real world. So you need to understand not just like, did something happen, but why did it happen? You need to be able to audit its behavior. So that means you need things like transparent reasoning stages, behavioral timelines to be able to audit decisions, and some thresholds for behavioral drifts. So this is where like supervision of agents becomes incredibly important. And this is a problem we really haven't had to deal with in traditional software because we have that constrained to the actual end user of the application. Okay, I know I've hit you with a lot of things here. I'm going to boil it down to basically 5 pillars of building enterprise agents for you. The first is having that mindset shift that agents are goal driven and thus behave unpredictably. The second is that process mapping is one of the most important parts of this process, where you need to determine what is deterministic versus what is adaptive and requires AI. And that's going to save you a lot of time in the long run. Next is having that modular design, very similar to traditional software best practices, having composable parts that can make the agents reusable. And then what's unusual about agents is the split of ownership between technical and business teams that's more compressed than it ever has been before. And then lastly, start simple with an MVP, add autonomy gradually, and track outcomes through your evals and audit your decisions. So that's all I've got for you. Thank you so much for being here. Hope you've had a wonderful conference. I'm Sam Julien. I run DX at Ryder. You can find me on social media everywhere as just Sam Julien, and I have a blog where I write about all kinds of things at samjulien.com. But thanks so much, everybody. Have a great evening.
Well, that was an in-depth and insightful, packed presentation, Sam. So thanks a lot for walking us through the entire phases. And I really like that. For me, like the particular slide where you talked about, the layer that added on top of, traditional SDLC phases was the highlight for me. But yes, thanks a lot to walk us through those flows. And I see we have a lot of questions. Let's start taking them one by one, starting with these. How can organizations ensure that collaboration doesn't slow down innovation but strengthens outcomes?
Yeah, it's a great question and a complex one. I would say I think getting really clear on the roles and responsibilities is a big part of that. Like making sure that's why we kind of offer that framework of the different roles. Um, because otherwise you have a lot of kind of stepping on each other's toes of what's the developer's responsibility, what's the business user's responsibility. So I think that is honestly, that goes a long way to just define like who is responsible for what, and then how are we going to communicate about these things. Are we going to have daily stand-ups, and who is the final decision maker? um, yeah, I think that's a good part of it.
Right. And we talked about, that you can never really be done. As you said, there are a lot of behavioral changes that come into play. So this question, right, it talks about how do you approach testing for adaptive, non-deterministic agents?
Yeah. So I think there's a few different layers to it. There are some kind of unit tests you can do for some straightforward testing as like the first round. There's multiple approaches to this. Then I think what I've drawn from Hamlin and Treya's work is that uh, the biggest thing here is to look at your data and categorize the failure modes. So go through, get a bunch of trace data, and start applying. They recommend, instead of doing it qualitatively at first, to do kind of a binary, like does this fit or not, and annotate all of the traces for like, is this acceptable or is this not, right? And then you can kind of break that down into the different failure modes that then you can test around. So say, for example, you come up with like, okay, there's like 4 core problems here that we need to improve, and then you can measure that and iterate on it. So I think that's the thing, is like, you're dealing with such a wide range of this like adaptive non-deterministic agents. So you kind of have to impose structure on it and be like, okay, here are the top three problems that we're having. Let's work on reducing that from a 40% failure rate to a 10% failure rate. And it's just I think one of the interesting things is sort of a tangent, but like one thing I'm finding is that as software developers, we really think in terms of like engineering, but with AI, it's really more of a scientific method approach. Like you really have to put on your sort of like data science hat and think in terms of like hypothesis and experiment and measuring and that kind of thing. And so that I think that's sort of like the single biggest thing you could do.
That makes sense. And we have, this question, which I'm sure a lot of folks would be wondering, that how does the role of product manager change with this shift to ADLC? How do you define a product roadmap and write user stories for a system that is outcome driven rather than feature driven?
Yeah, I think what changes is that the business user takes on this sort of interesting hybrid role. So the product manager is driving the actual, development and everything. Um, but the business user is going to have to be more tightly involved with that just because these are such domain specific applications. So I think there's a little bit more back and forth with the business user on that. Um, Getting their input on the stories and the requirements and that kind of thing.
Got it. And do you think multimodal data sets change scaling of agents?
To some extent, well, I'm sort of inferring the meaning of the question. I'm assuming what they mean by this is sort of like if you've got images and audio and that kind of thing, like how does that change? I mean, it in some ways, yes, it changes because the resources that are required for multimodal are more intensive if you're dealing with like a lot of data, a lot of images, that kind of thing. I think the overall principles don't change that much as far as like still needing to iterate quickly and have evals and that kind of thing. So that's my take based on how I'm understanding the question.
Got it. And there are two interesting questions. Let's start with this one. How should agents interact with legacy systems while maintaining performance and security?
That's a really big question. I mean, I think you still have to follow a lot of the same security best practices of uh, 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 authentication and authorization and OAuth and all of those things. So I think that's a big part of it. Um, Making sure that you have a policy in place for how you treat agents and like how you scope their permissions and their roles and that kind of thing. That's a huge part of it as well. That's a big topic
Right.
for sure.
That is definitely another topic to talk about in a different session, because it can be so subjective, when we speak about when we start to think around legacy systems, all different sorts of technologies, put together. And do you see another question that's interesting? I see a lot of questions that have popped up, but I don't want to be greedy and pick all the questions by myself. So if you see a
Yeah,
good one, let me know.
let me look at the. I'm trying to think because I think some of these were addressed in the talk.
Yes, some of these were addressed well enough.
Scoping. Uh, so this one's there's a good one here on. It says you've positioned the agent development lifecycle as a necessary successor to the SDLC. Could you elaborate on the single most critical first principle that distinguishes the ADLC and why traditional agile or DevOps practices fall short? So I think that goes to the whole element of you're deploying like behavior into the world. I think that's like the biggest thing that when we deploy regular software, it doesn't act on its own behalf. Like it takes a user to interact with it. Whereas with an agent, it might be lurking in the background, reading email, and then going out and sending Slack messages and things like that. And that I think is what everything else kind of flows from.
Right. And there is also, I mean, we did talk about, building outcomes, but how do you go about measuring ROI, when you're transitioning from SDLC to ADLC in large scale enterprises?
Yeah, that's a great question. I think the biggest thing is having that metric that you're driving. So, for example, we had a customer that was like a legal firm, and they were having this contract review process that was taking them a really long time. So instead of just saying like, let's build an AI legal assistant, it was okay, let's reduce the initial contract review time from 9 hours to 4 hours or whatever it was. And so then that can actually like translate into like, you know, dollars of like attorney's time and things like that. So I think that's a big part of it.
Right. And there's one more interesting question from Ashish as well, which says that how do you architect for fault tolerance and graceful degradation when agents fail in production?
I think you want to have a lot of fallback things. Like you want to have like retries and model fallbacks and things like that. Make sure that you're building that into your systems. um, those are sort of the two biggest things that jump to mind, like making sure you have a good retry process, like how many times you retry, and then have some fallbacks as far as like a different model to use or things like that. Don't put all your eggs in one API basket, in other words.
Right. And I mean, this is going to be again a very subjective question, but I'll just put it over here. Which is harder, testing deterministic apps, say SDLC, or adaptive agents, ADLC?
For sure, adapting adaptive agents for sure, because so many of the deterministic apps are you can do with unit tests and integration tests and things like that. The adaptive agents are just much more complicated.
Right. And I think that's about it. Like we've covered remaining questions while, Sam was presenting as well. So thank you so much everyone for posting so many questions and making the session engaging. And thanks Sam once again for taking time out of this out of your busy schedule for this. And thank you so much. We with this is going to be the last session for TestMu. You will soon be hearing from us on the closing note. And I hope you all have a great day ahead. Thanks Sam once again for joining in, and have a great day.
Thank you so much for
Cheers.
having me. Thanks everybody for being here. Bye bye.